So not going to have a very long opener here because, to be quite frank, there really isn't a flat Earth debate that happens. Nobody's ever had a debate on the flat Earth because there isn't a debate to be had on this. The Earth is obviously spherical. If we want to understand the world as people and as humans, then we have to, or at least we ought, set some rules for the best ways to go about doing that. And a lot of those rules involve things like, going out and actually observing things in the world. Things that include consistency, that, our models need to be consistent. Things like parsimony, our models need to account for the things that we expect them to account for and do so in explicative and simplistic ways. And I think that when we examine how humans would have thought the Earth was, like 6,000-7,000 years ago, it made sense to them. They didn't have the technology that we have today. They weren't capable of doing as sensitive measurements on not just the Earth, but various aspects of reality like we are today. And for this reason, I think that anybody would say, if you were alive 6,000 or 8,000 years ago, you'd probably think that the idea that the Earth is sort of this flat plane that perhaps just goes on forever wouldn't have really been that far-fetched. Most humans back then probably never went more than 50 miles outside of where they lived, and there's some humans that are like that today. But as humans developed, as we began to develop technologies, and particularly as we began to travel around the world, humans began to see things change about reality. Going from one place on the Earth to the other and noticing that the position of the sun in the sky wasn't the same. Noticing that different seasons the sun would be at a different position in the sky. Noticing that the moon goes through cycles that seem to be related to the amount of the moon that we can see relative to our position to the moon, relative to the sun. That there was a variety of things that we began to see. That when we would see a ship go off into the distance, we would see the bottom of it disappear and then the mast at the top of the mast disappearing last. All of these things are things that we would see, and I could go on and on and on for hours about the things that we observe about our reality just immediately without really needing much technology, and with our technology. And it seems obvious that the best model to account for why we see the world with the way that we do is that because the planet that we live on is spheroidal and is traveling at about 67,000 miles in its orbit around a massive star that is about 1.3 million times the size of our planet. We have seen these things elsewhere in reality numerous times. We know these are things that can form. We know the mechanisms, how they can do it. We can describe all this very, very well. So we know that the model is consistent. We know that it's parsimonious. It accounts for everything that we need to account for, and it explains why we see the world the way that we do. In terms of a flat Earth, I've never heard a model. I've never seen a model. All I have ever seen, all I have ever heard are attempts to confute the model that we do have, oftentimes by appealing to things that it can't explain, that it's been capable of explaining for decades, if not centuries. And that is all I have. Thank you.
So what were we all taught in school? We were all taught the same thing, that the Earth is a globe. This is what we're all taught. So when people act like there's no debate, this is so ignorant, you guys are so underinformed and uneducated, we were taught the same thing you were. And almost every single time, the person that ridicules the flat earther as dumb or ignorant doesn't even know a fraction about the Earth or the supposed globe Earth claims as the flat earther, which should be very telling to anyone honest. So what is the positive claim of the globe, which is what we're testing? Claim number one, the Earth is a sphere with a radius value of 3,959 miles. And a supposed circumference of 24,901 miles. This is a positive claim, a shape claim of a sphere with a size claim, a dimension claim of a specific radius value. This is a positive claim. It has the burden of proof. Claim number two, the Earth is supposedly spinning over 1,000 miles per hour at the equator while revolving around the sun 66,600 miles per hour on an axial tilt of 66.6 degrees. This is, of course, a positive claim of axial rotation. It has the burden of proof. Okay, claim number three is that this spinning magic globular Earth with the radius of 3,959 is sitting in a vacuum of space that is encompassed in a near perfect vacuum of 10 to the negative 17 torr. And this is a place that you can actually go to. This is a third positive claim. These are the three fundamental claims of the globe Earth. You have the burden of proof as a globe proponent to prove that this is in fact the case. So the heliocentric model has the burden of proof for all these positive claims. Okay, so that's just objectively the way that it is. We don't have to prove a negative. We don't have to explain any question you can come up with. the burden of proof is on the one making the positive claim, as the heliocentric model is. Wait, isn't saying the Earth is flat a positive claim? Well, yes, yes, it is. So you have the burden of proof, right? Flat is the description of a surface. Flat is not a shape. Okay, so we have the burden of proof to show that the surface of the Earth is flat, because that is our positive claim. But radio waves can be sent over 10,000 miles with no Earth curvature obstruction whatsoever. How is this possible? Of course, it's propagating over a horizontal plane, 10,000 miles, no Earth curvature obstructing it whatsoever. Seconds have been used to successfully navigate for hundreds of years and require the Earth be a horizontal plane as you take an elevation angle to a celestial object, and then it comes down to the plane to have your corner pocket. An elevation angle is to a horizontal. You cannot in any way use a sextant successfully without the Earth being a horizontal plane, and it's worked for hundreds of years for hundreds and hundreds of miles. Next, the horizon has been seen over 10 times the geometric limitations of the globe. The entire globe model depends on the accuracy of this claimed radius value. Everything. So this radius value has been falsified. So welcome to flat Earth. So do you have any contention with my opening statement? Do you agree that making the positive claim that the Earth is a globe has the burden of proof?
Yeah, that burden of proof has obviously been met.
Okay, so you want to take it step by step. The first claim is that it's a sphere with a radius of oblate spheroid with a radius of 3,959 miles. Would you like to enlighten us how that was established and proven?
I don't know. I'm not a geologist. I don't know how they measure that.
Okay.
I would assume probably using trigonometric methods by measuring an aspect of the Earth and then utilizing mathematics to extrapolate that to the entire sphere, which could be done. I'm also not a, geometrician, I think they're called, so I couldn't tell you how to do that either.
Okay. Well, you did just say that you know it's been proven, and so what you've immediately admitted is that you actually do not know that it's been proven because you're not even aware of the methodology.
I do, though. The fact that I don't know the mathematical methods through which it was proved doesn't mean that those methods haven't been used to prove it.
Well, how can you know something if you don't know it?
I don't know what that means.
Well, how can you claim to know something as a fact if you don't even know what it is you're claiming as fact?
I do know what it is I'm claiming as fact, that the Earth is a sphere.
How was the radius verified?
I don't know. If you wanted to know that, my question would be, why haven't you asked a geologist? Did you ask them that question?
Yes.
Did they answer it? I'm sure they answered it. What was the answer that they gave?
They tried to invoke geodetic surveying.
Geodesic surveying?
Geodetic.
I don't think I know what geodetic is. I know what a geodesic is. I don't know what geodetic means, though.
We physically measured the surface of the Earth and falsified the claimed radius.
I see. I just Googled it in like 10 seconds. I found out how we know what both the circumference and the radius and the diameter of the Earth is. And it's exactly what I said. You use trigonometric methods to measure curvature over a particular area of the Earth. You could say maybe even over 100 miles, and then you can use that to calculate what the whole diameter of that circle would be. If you have part of the circle and you know the angle at which it's curving, then you can essentially piece together what the size of the entire circle would be.
So you're saying if you know the angle at which it's curving, you can determine the radius value, but the way that you know that curvature rate is the radius value. So that would be
I don't know what that means. We know it by looking at differences in the angle of the sun. I mean, this was calculated thousands of years ago because this kind of math has been around for thousands of years. Humans have been doing this for thousands of years. We are not in rocket appliances right now. This is very, very simple stuff.
Light works that the sun is distant. That's the only way light could work.
No, light moves in straight lines.
Okay, so is there anything such thing as divergent rays? Is that a real thing?
Divergent rays? Yeah, there are ways to do that. Yeah.
Okay, so that's not how light works.
The electromagnetic radiation, yes, it propagates orthonormally, I believe, if it's not interacting with a form of medium. Yes.
It actually propagates in a transverse movement. Wave-like.
Do you not know what orthonormal means?
Orthonormal, no, you enlighten me.
Orthonormal. One oscillates this way, one oscillates this way. They're orthogonal or at 90 degrees to one another and normalized of unit length. So they're normal. Ortho, normal.
Is it transverse? Yes or no?
Oh, Lord have mercy.
So you don't. Okay, so the
So
propagation
the
of
concept of orthonormality would subsume the concept of transverse.
right. Okay, so can you provide evidence that the sun is 93 million miles away, or is it just a claim?
We can measure that,
Okay,
and
that's
he
the
he
claim.
figured that out just from walking from two cities. Yeah, that was the claim. Well, actually, that's not the claim. That was the observation. He determined that there is curvature on the surface of the Earth because these things that we see in reality happening.
But did you know that if the surface was flat and the sun was more local, you would get the same results?
How so?
Because the divergent rays would create shadows relative to the angle of the local
What do you
light.
mean by divergent rays?
They converge to the point of light, the source of light, which is the sun. So
Isn't that how all lights work?
okay, so, well, you just a second ago they're all parallel. So anyway,
Yeah, they travel at straight lines outward from the source in all directions. Like that's kind of how field mechanics works.
well, the globe Earth kind of doesn't claim that any of the sun's rays on Earth is divergent. They claim they're parallel.
I don't know what you mean. They're parallel in terms of them coming from the sun. The light just moves in straight lines through space.
Right.
Yeah.
Right. So if the
And it's
sun's
divergent in the sense that all those straight lines would diverge back onto the sun, the point of origin.
but
where the light is sourced from.
The globe Earth model has just a small portion of the light of the sun hitting the Earth, and they're all parallel. If the Earth is smaller, or if the sun's more local, then it has divergent rays locally on the Earth. It's a fundamental difference.
I have no idea what you're talking about.
Okay, so you have no. First of all, that wasn't even claimed.
Like optics isn't this hard. Actually, optics is a pretty difficult field. It's boring too.
Okay, well, that's called a straw man fallacy, my man.
No, it's not.
Yeah, yes, it is.
What's a straw man?
Yeah, you just straw man a model of the Earth, saying that if the Earth's a disc with a ball above it, then it'd cover up the whole disc. That is just an unfounded claim that no one on this side has ever made. There's something called
Except all of you.
Light. There's something called the attenuation of light.
Sure.
So why would the light go forever if it's a small local light source with attenuation?
What do you mean? Why would the light go forever?
You just claimed to cover the whole Earth. Why would it cover the whole Earth if it's a small local light source with attenuation?
Because attenuation happens when electromagnetic radiation interacts with matter. So
correct.
You wouldn't expect that to happen until it struck the Earth.
Wait, is there not matter in the atmosphere?
Not very much, no.
Oh, so there's not an absorption rate of air when it comes to light? There's not an absorption rate of light?
A very small one. It's more, I think, of a refractive index, but...
Okay, so there's an attenuation rate in the air.
A very, very small one, yes. It doesn't really matter. It doesn't just be in a genetic fallacy. You're trying to appeal to the source as a means of falsifying the information when the source of the information isn't really relevant here.
I'm not. I'm appealing to the fallacious methodology they used. You are ignorant of the method.
What fallacious methodology? Yeah, and the funny thing is you haven't been able to explain them to me, so I don't think you know much about them either. Yeah. I never claimed to know everything, and I don't actually know how we've even today measured the circumference and the radius of the Earth. I really don't. I've never asked, but I'm sure if I Googled it, how can we measure the circumference of the Earth, I'd get perfectly fine answers that make sense and have a lot of valid mathematics to back them up. I mean, I'm sure that anybody, if they really wanted to know these things, could just Google them or call a university and ask a professional. My question would be, why haven't you done that?
Okay, but maybe we should do this, right? You realize that the entire model depends on that radius value being accurate. If that
what do you mean? We could change that value. The Earth can be larger or smaller. It could be more spheroidal or less spheroidal. The point is that it's a sphere.
No, it can't. It objectively cannot be.
So you're saying that if it couldn't, but it can, because there are planets that are.
Okay, so you don't understand it. So say the Earth has a certain size. That's how we've come up with everything else in the model, like relative distances and sizes of the other bodies in the solar system, cosmological distances. If you don't understand this, it doesn't make it not true. I
definitely understand this. I study astronomy.
Okay, so to have orbital trajectories dependent upon the mass, which is dependent upon the size of the dimension, which displaces a certain amount of mass in the curvature of space-time. So the radius of the Earth is directly related to your entire claim, as is day and night cycle. It is objective.
No, actually, no. Our day-night cycle would be related to the rate of rotation of the Earth about its axis.
And the way you come up with the rate of rotation is how much it needs to spin within a certain period of time based on its size.
No, you can make the Earth larger, and it could still spin and have a 24-hour day cycle,
If the
day-night
Earth
cycle.
was larger, if the Earth was larger, would it have to spin faster to maintain the same day cycle?
I would assume so. Conservation of momentum is kind of a thing that exists in reality.
Yeah, yeah. So everything depends on that radius value being
No.
correct, because the
Do
1,037
you think that the Earth couldn't exist if those numbers weren't exactly what they are?
What a straw man! Do I think the Earth?
No, that was a question, not a straw man. I was asking you a question.
Do I think the Earth couldn't exist?
Yeah, if the Earth was larger, do you think that would just somehow it couldn't exist? The Earth can only ever be one size if it's a sphere. That seems to be what you're saying.
Yeah, because we know distances to different locations on the Earth, right? And so if that radius value changes, those known distances are
well, of course they would change. The planet would be larger. Why would we not expect that?
But we know the distances, though.
Yes, because the planet is the size that it is.
So if it was falsified, then it could not be a sphere.
Well, no, it would just mean that it's either larger or smaller than what it is.
And that all the distances to known locations are wrong.
Well, sure, because the Earth is either larger or smaller than what we thought it was. It's still a sphere.
Well, that can't work because they're verified distances.
Yes, they are, because the Earth isn't larger or smaller than what we've measured, because we've measured how large the Earth is.
Okay, we'll let the audience decipher that double speak.
90% of the time, I have no idea what the fuck I'm talking about.
So if the radius value is wrong, the entire model is wrong. This is just objective.
I don't know what you mean when you say that. You keep essentially making this argument that, well, if the Earth were any larger or any smaller, all of the values about distances on the Earth and the amount of velocity needed to escape Earth's gravitational field and the radius at which something can be in a free orbit around Earth would all change and your model would fall apart. No, it wouldn't. It just means that the Earth would either be larger or smaller than what it is. It doesn't matter that the Earth is the size that it is. We measure that it's the size that it is because it is that size, but the idea that if it were larger or smaller, if those values were different, all of a sudden we can't explain anything. No, that's not how this works. I'm sorry, it's just not how this works at all.
Well, they claim the radius is under 4,000 miles. I've said something that's objective. You've disputed it, but I don't want to keep going in circles. If the radius value is wrong, the entire model is wrong.
I still don't know what that means.
The highest levels of academia on your side would agree with that.
No, they wouldn't.
Okay. So,
they would say that if somehow the size of the Earth, if you change the values of the parameters of the Earth, its radius, diameter, circumference, its mass, its density, there are things that would change. You could potentially make it so that life wouldn't have been possible on this planet. But nothing about how we understand of what we understand, rather, in terms of the way reality works, relativity, thermodynamics, classical mechanics, quantum mechanics, none of that's going to change. And it's through those methods that we know that the Earth is spheroidal. So the methods that we've used to determine the size of the Earth are not going to be changed if the size of the Earth were somehow changed.
Okay, so objectively, man, I'm not going to keep arguing it. If the size of the Earth is wrong, the entire model is intrinsically wrong. It's all dependent upon the mass of the Earth. Day and night cycle, gravity, orbital trajectory.
Yeah, but like I said, those are all parameters that depend on what the size of the Earth is. We could go to anything. The size of the mass of the sun matters too. If we changed the mass of the sun, we'd get the same things. Things would start looking a little different. That does not mean that gravity somehow works differently. That does not mean that our physics does not work and doesn't give us accurate descriptions of reality. What you're talking about isn't that the math doesn't work anymore. You're just talking about changing the parameters within it. Yeah, that's going to change how the system evolves through time. But the fact that the system will evolve through a set of laws that we can determine that are based in symmetries and conservation principles, all that stuff, that's all going to be the same. Changing the parameters doesn't really mean anything for the physics of how we describe how systems evolve. A way to measure the curvature of the Earth, yeah. Walk from one place to another. Walk from Tampa, Florida, all the way up to Boston, Massachusetts, and measure the difference in the position of the sun at the same time of day.
Okay, so
and you will notice it will change.
Yeah,
you'll be able to use that to determine the angle of curvature of the distance between Tampa and Boston. And then
So
from that, you could essentially extrapolate all the other pieces and get the full circle and be like, oh, so yeah, the object that I'm standing on is a sphere and its circumference would be this amount. And then from that, I can determine what the radius and what the diameter would be as well.
right, but so you have to assume the Earth's a sphere. So how
No,
can
you don't. You would. The thing there is what you're observing when you make that walk is that you're walking on a curve. That's not an assumption you go in starting with. It's something that you get out of doing it. That's a result of what you're doing. It
No.
accounts for why you see the world the way that you do. So on your model or lack thereof, you would have to account for why we can experience a curvature to the Earth's surface when there really isn't any.
We literally don't experience a curvature to the Earth's surface at all, ever in the entire.
Why does the position of the sun change when you move? Holy shit, I'm going to get this wrong. I think it's longitude, I think, is this way. Look, guys, I'm not a surveyor. I'm not a geologist. I do physics. Okay, I don't know this stuff. I think this is longitudinal. Correct me if I'm wrong. But when you move longitudinally, if I'm correct on the Earth, the position of the sun changes. The position of the stars change as well.
Okay. Yeah.
And their change is proportionate to a definite curvature that we can measure on the surface that we're walking. Why?
Okay, because that would happen on a flat Earth, and I'm trying to explain it, but you really have impulse control issues. So when they looked at the sky, they reverse engineered the cyclical nature of it to apply it to a spherical assumption. Yeah, they all revolve around Polaris. We don't actually feel the movement. Your argument is that it's so big you wouldn't feel it. Cool. Still, objectively, we don't feel it, though. That's objective.
Sure.
And then we see the stars move. You claim that it looks like they're moving in a circle, but they're actually sitting still. It's just because
the stars aren't sitting still, no.
Yeah, relative to our reference frame.
Well, yeah, sure, but at that point, I mean, there is no wait, what do you think motion is? You do realize there's no such thing as absolute motion, correct?
Why are you diverting?
No, you're the one that wanted to divert. You said relative to our reference frame. Well, of course.
Yeah, because you just said that they weren't still, and I rebutted.
Yeah, the stars are moving. Yes.
Oh, the stars are moving in.
Yes,
yeah,
they are. The whole. You do realize the Milky Way galaxy is rotating, correct?
Cool. Yeah.
Yeah. So obviously, the stars and our solar system, which is around a star, would be moving with all the other stars. We do not exist for long enough to really see that. I mean, for Christ's sakes, it takes the Milky Way galaxy 225 million years to do one rotation.
That's all pseudoscience, fairy tales.
I don't know what you mean by pseudoscience. These are things we've measured quite well. In fact, we've measured the rotation of not just our own galaxy, but many other galaxies so well that we realized that the amount of baryonic mass that is present in the galaxies isn't enough to account for why they're held together, despite the fact that they're rotating so quickly, which is why we have a thing like dark matter. There has to be some extra mass to create the gravitation to hold the galaxies together because they're rotating too quickly to do it on their own with just the mass that we can see. So yeah, we do know know that galaxies rotate. Well, all of this stuff is obviously tangentially related, and it all comes back to proving my point that the methodologies that I rely on and that everybody else in the sane world here relies on obviously work, and those methods tell us that the Earth is a spheroidal ball that is rotating about an axis and orbits a star.
The default position based on all observable phenomena is that the Earth doesn't move, it's stationary. To do anything in the practical world successfully, you must assume it's stationary, as in fly a plane, shoot a bullet, you name it, or you would not be able to successfully implement practical use. So actually, we just treat the Earth as a stationary. The sky moves over top of us, all circling around Polaris, the North Pole star, over the North Pole, quote unquote, just a geographic location you're not allowed to go to, and it continues to reset. The default position is that. Now, you're making a claim antithetical to observable phenomena, so you have the burden of proof times a million. You're making a claim antithetical to what's actually observed and can be verified. So to flip the script and pretend that if we don't blindly believe your claim antithetical to all observations, we are out of pocket is a bit off-putting, right? It doesn't really make sense. So there's Einstein himself. I'll help you out. I'll throw you a bone, right? Einstein himself said, I've come to the conclusion that there is no optical experiment on the Earth that will ever prove the Earth's movement, although we know it revolves around the sun. So there is no earthly observation that can prove the Earth is spinning according to your own side. It's just philosophical. It's theoretical. And that's just that. And so, yeah, unless you got some scientific evidence, it's just sophistry.
So I just really quickly want to recap. I did outline what is evidence, and then I explained why it's evidence and how we know that it's evidence. I didn't really hear much in the way from you in terms of responding to that. You did cite Einstein, and that quotation is correct. But the thing that is often left out is what Einstein was speaking about there was movement of the Earth through the ether. This is why he referred to an optical experiment. We are never going to be able, if the ether, the luminiferous ether, is a real, and there's still people that believe in even that. It's if that were a real thing, there's no experiment, there's no optical experiment we would ever be capable of doing that's going to be able to determine the Earth's movement or any drag on Earth or on light being emitted from Earth as it moves through that ether. So that's what Einstein was referring to. He wasn't referring to any way of detecting that the Earth moves. But since you brought up Einstein, let me bring up my favorite piece of evidence in favor of the flat Earth, and that's Einstein's field equations. I don't know if you've ever heard of those, but obviously Einstein is a source that we can both agree is reputable. Otherwise, I don't think you would have cited him, even though the quote you cited had nothing to do with the motion of the Earth simpliciter, but the motion of the Earth through the ether, which is also a thing that isn't real. Einstein's field equations describe essentially what gravity is, and they tell us that mass energy has an effect on space-time, and we don't really fully understand yet that because we don't have quantum theory of gravity. But essentially, the point that I'm getting at is that when we look at Einstein's field equations, what we see is that there would be something called hydrostatic equilibrium on massive enough objects. Once an object gets massive enough, there's going to be a tension on its surface. There's going to be a tension on the object as a result of its own gravitational force, the field acting on the object, creating the field. And that material is going to have a resistance to that tension, and it's going to find a shape that can most reduce the tension across the surface of that object. And as anybody versed in material science or physics knows, that's a sphere. And that is why stars and planets are spheroidal, because of the hydrostatic equilibrium between the tension on that object as a result of its own gravitational field and the resistance of the material, which is given like by the Pauli exclusion principle and things like that, but I'm not here to talk about quantum mechanics, that results from the material that is creating the field that is then putting the stress on it. And it's sort of a symbiotic relationship between those two.
Cool. So it's just theoretics. 1905, he attributed constant speed to light, which actually quantum mechanics pretty thoroughly debunked that. They cannot coexist. To even say the word theory of relativity and quantum mechanics in the same sentence is actually laughably ignorant. But anyway,
wait, do you not know what relativistic quantum mechanics is?
I know that relativity can't coexist with quantum mechanics.
Well, general relativity has not been reconciled with quantum mechanics. Special relativity has been.
Space-time is conceptual, right? So space, the idea of emptiness, nothingness, of privation. Time is a quantification method that we use to quantify passing. We've put it into a coordinate system, right, using breadth, height, width into quote-unquote space to determine this effect of a gravity well, and that gravity is the effect of the bending and warping of space-time. Anyway, on its face, it's inadmissible. Conceptual abstractions cannot in any way have physical properties. It's also fallen apart as early as the 50s. The galaxy rotational speeds debunked it. Also, as recently as modern times, we now have dark matter, dark energy making up 95%. That is not accounted for in relativistic application, and it's off with 95% of its occupancy claim. So it's not even close to being viable mathematically yet, and none of that even matters. It's all begging the question, because on the local scale on the Earth, you never account for gravity, you never account for spinning, and you never account for Earth curvature. This is just objective, and we need scientific evidence before we believe cartoons from governmental agencies. So we need actual physical scientific evidence, bro.